Welcome to the Explainer. All right, today we're tackling two super important ideas for anyone who builds things on the web: rate limiting and rate throttling. They sound almost the same, right? But trust me, they're used to solve totally different problems.
Okay, so let's set the scene. Imagine this. Your API is a hit. It's blowing up, but that's kind of a double-edged sword, because now it's getting absolutely slammed with requests. Your servers are starting to sweat, and you just know it's about to fall over. What's the plan?
Well, to handle this chaos, you've got two main defenders in your toolkit. And honestly, it's best to think of them as two very different characters. You've got the toughest nails bouncer, and then you've got the calm, cool, and collected traffic controller. So let's get to know them.
All right, first up, let's meet character number one, the bouncer. This is our metaphor for rate limiting. Picture a bouncer at the hottest club in town. You know the type, super strict, no exceptions.
And this analogy works so well because it's so direct. The bouncer doesn't care about your story. Their only job is to enforce one rule: the club is full. Once that limit's hit, the door is shut. Instantly. No waiting list, no let me see what I can do. You're just not getting in.
Okay, so in more technical terms, rate limiting is just that, a hard cap. It's a rule that says you can only make X number of requests in Y amount of time. You know, like maybe 100 requests a minute. And the second you hit request 101, bam, rejected immediately.
So what's actually happening behind the scenes? It's pretty straightforward, really. Think of it like a clicker. A request comes in, click, the counter goes up by 1. The system looks at the counter. Are we still under the limit? If yes, great, come on in. If no, sorry, door is closed. Then after that time window is up, say a minute, the counter just resets back to 0. Simple as that.
And from the user's perspective, this feels like hitting a brick wall. You don't get a please wait message. Nope. You get that dreaded HTTP 429 too many requests error. It's the server basically yelling, hey, you're doing too much, cool it and come back later.
Okay, so here's the key question. When do you actually use the bouncer? Well, you call on rate limiting when you think the traffic might be sketchy, when it can be harmful or malicious. Think of it as your first line of defense, a security tool. It's perfect for shutting down bot attacks, trying to guess passwords on your login page, or stopping someone from spamming your system with SMS requests. It's all about protecting your service.
All right, that's the bouncer. Now let's shift gears and meet our second character, the traffic controller. And this is our stand-in for rate throttling. Think patient, organized, methodical. So for this one, picture a big wedding dinner buffet. The key thing here is that everyone is a welcome guest. No one gets kicked out. But you can't have everyone rush the buffet table at once, right? The kitchen would explode. So you form an orderly line. That's throttling. It guarantees every single request gets served. It just controls the flow. So, see the difference? Unlike our bouncer who just says no, the traffic controller says yes, absolutely, just form a line. It accepts all the requests and puts them into a queue. Then your backend system can just process them one by one at a pace it can actually handle. It smooths out those crazy traffic spikes.
Yeah, the whole workflow is totally different. The requests come in, they get funneled into a queuing system, like Kafka or RabbitMQ, and then your backend services just pull from that queue at their own comfortable speed. It's this separation, this decoupling of the flood of requests from the actual work, that's the secret sauce for stability.
And think about the user experience. It's so much better. Instead of getting an angry error message, you get a friendly, okay, we got it. You get a confirmation that your request is in the queue. Maybe it even tells you you're number 45 in line and it should take about 9 seconds. It's awesome because your request wasn't just tossed in the trash.
So when do you bring in the traffic controller? You use throttling when you're dealing with a huge amount of good, valid traffic. The classic example is a Black Friday sale. Every single one of those requests is a customer trying to buy something. You don't want to turn them away. Or think about a user uploading 100 photos at once. It's all about managing legitimate traffic you absolutely want to keep.
Okay, so we've met the bouncer and the controller. Let's put them in the ring side by side for a little showdown. This is where it all clicks.
If you boil it all down to just one idea, this is it. Limiting blocks, throttling delays. One is a brick wall, the other is a waiting room. That's the fundamental difference.
And this comparison makes it super clear. Look at the goal. For limiting, it's all about safety and security. For throttling, it's stability and resource management. That one difference changes everything else. The mechanism, the response you send back, it all comes down to why you're doing it in the first place.
So let's put this into practice. Here's a super common interview question you might get. You're running a huge flash sale. Your site is getting hammered. Why would it be a terrible idea to use a rate limiter, our bouncer, in this situation?
And the answer is all about the money, really. Every single one of those requests is a potential sale. It's a customer with their wallet out, ready to buy. Blocking them with the rate limit? That's like having a bouncer at your store on Black Friday, turning paying customers away at the door. It makes no sense. You throttle so you can eventually take everyone's money.
All right, so how do we make sure this sticks in your brain forever? Let's finish up with the ultimate cheat sheet.
Look, if you forget everything else we talked about, just remember this one little phrase. Limit blocks, throttle clocks. It's perfect, right? Limit blocks, it stops traffic cold. Throttle clocks, it makes traffic wait, watching the clock tick by in a queue. That's all you need.
And that little phrase also reminds you of the purpose. Limiting is for safety. It rejects the bad guys. Throttling is for stability. It delays the good guys to keep your systems from falling over.
So there you have it. The next time you're designing a system and you know it's going to get hit with a ton of traffic, you'll know exactly what to ask. Is this traffic a potential threat, or is it a welcome flood of users? And you'll know which call to make. Are you calling in the bouncer or the traffic controller?